Hey guys, Mr. Middleton here. Welcome. We're on the second lesson of the first unit of geometry. So we're still talking about the basic building blocks, being able to name and identify um, um, pieces and lines and all that stuff. So at the end of this lesson, you should be able to name and define segments and rays, and you should be able to tell the difference between different types of non-intersecting lines and planes. Okay, so a segment is a part of a line consisting of two endpoints and all the points in between. So a segment is a part of a line consisting of two endpoints and all the points in between. Alright, so it says name all the segments on the line K below. So line K, all the segments, we can name a segment just by the endpoints. So we have FG. Remember that when we name a segment, we're going to name it with this line over top of it. Does not have the arrow, shows that it does not continue. I'll say FH, going through this kind of systematically, and I'm going to go to G, GH. Okay. Notice that I don't say GF and HF and HG. I don't just flip the order. That's not a new way to name the segment. How many points are on FH? Okay, I'm going to do this. Infinity. Okay, even though there are only 3 points that are named, remember that there are a bunch of points. A point is a location with no size. So, a bunch. Okay, so those are segments. It just, boom, they end. Most things that we talk about or deal with in real life are segments. Remember, lines go on forever. Segments have endpoints. Okay. Alright, next we are talking about rays. A ray is a part of a line consisting of one endpoint and all the points of the line on one side of that endpoint. Okay. Opposite rays are two different rays with the same endpoint. Opposite rays are two different rays with the same endpoint. These always form a line. Okay, so opposite rays have to form a line, otherwise they are not opposite rays. Okay, so the best way that I remember rays is the sun. Okay, so the sun has rays, that's what these little lines usually are, but it starts at the sun, that's our endpoint, and then it goes on forever. Okay, so ray, endpoint goes on forever in a direction. Okay, and we'll look at opposite rays down here. So let's go through these exercises using this diagram to the left here. Follow along with me for a few, I guess. It might be a good idea just to follow along with all of these. So number one, it says name one ray with endpoint C. So here's C, endpoint. Okay, C, D. This is one ray. And the way that we name this, we always start with the endpoint. Where is it coming from? It's coming from C. And notice this notation. We have just a line with an arrow, one arrow. That means it stops at C and goes on forever in the direction of D. Okay. Are BD and BC the same ray? Well, let's look at that. From BD, that means it starts here and goes to the direction of D. From BC, it starts here and goes to the direction of C. Are they the same? Yes. And the reason that they're the same is that C and D are the same direction from B. Okay, so they are the same because they lie in the same direction. Everything to the right of B includes C and D. Next question, are AB and BA the same ray? Okay, let's look at that. So AB, that means it goes from A to B in this way. BA means it goes from B to A this way. Are they the same ray? No. They have different endpoints. They have different endpoints and they go in different directions. they cannot be the same ray. Okay, hopefully that makes sense. Number 4, are ray CD and ray DB opposite rays? So ray CD goes this way. Ray DB, okay, goes this way. Are they opposite rays? No. Opposite rays have to have the same endpoint. So, different endpoints. And then last one, we have CB and CF. Are they opposite rays? So CB goes here, CF goes here. Are they opposite rays? That answer again is no. Okay, and here's why. Opposite rays always form a line. CB and CF don't form a line. They actually look like this. This is not a line. It's more of an angle. Okay, so no, they don't form a line. Alright, so there we go, dealing with some rays. On the back side, let's talk about some non-intersecting lines. Okay, there are two types of non-intersecting lines, and so we'll talk about them. Usually people know the first one, but not really the second one until geometry class. So the first one is parallel lines, and we've talked about that in algebra, and even before that you probably have heard the word parallel. Parallel lines are coplanar, lines that do not intersect. Skew lines are non-coplanar lines. Hope I'm spelling coplanar right. Okay, so parallel lines, pretty easy. You might see something like this if you're graphing or, on a road or something. Usually the lines on the edges of your lane that you can drive in are parallel. Okay. But skew lines are something new for a lot of people. So to visualize this, you can use the Interstate and 69. Okay, so you have Interstate 69, in Illinois Road. So you have Illinois Road goes through something like this, but then 69 intersects it. Well, on a map, if you're looking at the map over, you'll see that it intersects it, but in actuality, it doesn't intersect it. It actually goes over it. Okay, so car here, okay, won't run into this car, not because they're going in parallel directions, but actually because these are skew. Okay, they're traveling on different planes. One plane's lower, one plane's above it. Okay, and that's why it's okay. Okay, planes can also be non-intersecting. They are called parallel planes. Okay, there is no such thing as skew planes. Okay, so here's what we're going to do. We're going to name all the lines parallel to CB. So we have CB here. We're talking about all the lines that just don't hit it because they're parallel. It means they have to be coplanar, and that's EF. Alright, and that's it. That's the only one. Name all the lines parallel to AD. So we look at AD down here. Parallel to it would be CF and BE. And remember, feel free, guys, if you feel like you know what's happening, to pause it and then fast forward a little bit to see if you're on the same page. And if you're not, go back and watch and see what you did differently than I did. Okay, name a line skew to BE. So again, skew means that it doesn't touch, but it's not because it's parallel. So BE, I see that AC and DF. If they were on the same level, they would definitely run into each other, but in this case they don't. Describe the intersection of CF and ED. CF and ED don't intersect, but it's not because they're parallel, it's because they're skew. Okay. Name a pair of parallel planes. Remember, with planes we use 3 points, so ABC, front face should be parallel to DEF. Those two are parallel. You can write it like this. ABC is parallel. Those two lines. Kind of slant. It means parallel. Then where do CFD, so CFD, okay, remember we only need to name 3 points, but CFD is that whole bottom face. And EBA, EBA is that whole back face. So where do they intersect? They intersect at AD. Bottom and the back. AD is part of both the bottom and the back. Alright, now if you want to pause and try to do this on your own, go ahead and check back with me. If not, follow along here. So name a plane parallel to JAG. JAG is this left side of the box. The right side of the box is BHI. Name all lines parallel to BC. So BC is here. So I see HI is parallel, and GJ is parallel, and AD is parallel. Name all lines skew to BC. So BC is here. Okay, skew means it doesn't touch, but only because it's not sharing the same plane. So AG is skew. DJ is skew. JI is skew. GH is skew. Hope I'm not missing anything. AD, AG, DJ, GH, JI. Okay, I think that's it. Alright, and then name all lines parallel to GHA. So GHA is the top. Okay, lines that are parallel means it doesn't touch probably, well, definitely will have to lie on the same, or on a parallel plane. So parallel plane with the top would be the bottom. So all the lines that are parallel would be DJ, CI, make sure I have my notation correct, JI, and DC. So basically the lines that make up the parallel plane. Alright, there we go.